Hey everyone, Satish here, and today we're diving deep into the world of Apache Cassandra, specifically its compaction strategies. Now, if you're working with large-scale data, you know that storage can be a real pain. Cassandra, being the beast it is, uses this thing called compaction to keep your data tidy and your performance snappy. Think of it like cleaning your room. Over time, things get messy, right? You've got clothes on the floor, empty pizza boxes, it's chaos. Compaction in Cassandra is like finally tidying up, getting rid of old, unnecessary data, and organizing everything so you can actually find what you need. And just like there are different ways to clean your room, I'm more of a shove it under the bed kind of guy. Cassandra offers various compaction strategies. Choosing the right one is crucial because it directly impacts how efficiently Cassandra can read and write data. We're talking about the difference between finding that cute cat video instantly and waiting for what feels like an eternity. So whether you're building a high-traffic website, a real-time analytics dashboard, or just want to become a Cassandra pro, buckle up. We're about to explore the most popular compaction strategies, understand their strengths and weaknesses, and by the end, you'll know exactly which one to choose for your specific needs. Let's get started. First up, we have the size-tiered compaction strategy, or STCS as the cool kids call it. This is the default option in Cassandra, and it's like the one-size-fits-all t-shirt of compaction strategies. It works for most situations, but it might not be the most flattering. STCS works by grouping similar-sized SS tables together. Think of SS tables as containers for your data. As these containers fill up, STCS merges them into larger ones, kind of like combining your Lego bricks into bigger and bigger structures. Now, the good thing about STCS is that it's relatively simple to understand and implement. It's great for write-heavy workloads because it reduces the overhead of constantly merging small SS tables. However, there's a catch. Remember how I said it might not be the most flattering? Well, STCS can lead to something called read amplification. Imagine searching for a specific Lego brick in your giant merged structure. It's going to take a while, right? Similarly, when you're reading data with STCS, Cassandra might have to look through multiple SS tables, even if they don't contain the data you're after. This can slow things down, especially if you're dealing with a lot of reads. Next up, we have the leveled compaction strategy, or LCS, the sports car of the compaction world, sleek, efficient, and built for speed. Unlike STCS, which groups SS tables by size, LCS organizes them into levels, kind of like a pyramid. At the bottom, you have the smallest, most recently written data. And as you go up the levels, the SS tables get larger and contain older data. This tiered structure is what gives LCS its edge. Remember the read amplification issue with STCS? Well, LCS tackles that head-on. By organizing data into levels, LCS reduces the number of SS tables Cassandra needs to search when reading data, making your reads lightning fast. This makes LCS perfect for read-heavy applications where performance is critical. But of course, there's a trade-off. LCS has higher write amplification than STCS. This means that when you write data with LCS, Cassandra needs to do more work to merge and compact the SS tables, which can put a bit more strain on your system resources. However, if you're prioritizing read speed, LCS is the way to go. Now let's talk about time window compaction strategy, or TWCS, the time traveler of compaction strategies. This one is specifically designed for time series data think sensor readings, stock prices, or anything else that's collected over time. TWCS is like having a perfectly organized library of historical records, where each shelf represents a specific time period. The beauty of TWCS is that it minimizes SS table overlap, meaning Cassandra doesn't have to waste time searching through irrelevant data. This makes it incredibly efficient for handling time series data, especially if you're frequently querying data within specific time ranges. It's like having a time machine for your data. However, TWCS isn't without its limitations. While it excels at managing recent data, it's not the best choice for storing data over very long periods. As data ages, TWCS can become less efficient, and you might need to consider alternative strategies for archiving or purging old data. Now it's time to address the elephant in the room date-tiered compaction strategy, or DTCS. Think of DTCS as that friend who used to be really cool but is now a bit outdated. DTCS, like TWCS, was designed for time series data, but it's been deprecated in favor of TWCS. DTCS worked by organizing data into daily SS tables, which was great for accessing recent data but became a pain when dealing with older data. It's like trying to find a specific newspaper article from a year ago in a giant pile. Not fun! So, while DTCS might still be lurking in some older Cassandra installations, it's best to stick with TWCS for your time series needs. Think of it this way. You wouldn't use a flip phone when you have a smartphone, right? Finally, let's talk about hybrid compaction strategies. The mixologists of the compaction world. This is where things get really interesting. With hybrid strategies, you're not limited to using just one compaction strategy. You can actually combine elements from different strategies to create a custom solution tailored to your specific needs. It's like creating your own signature cocktail. Want the read speed of LCS with the time series efficiency of TWCS? No problem, mix them up. Need a strategy that can handle both write-heavy and read-heavy workloads? Go ahead, blend away. Hybrid strategies give you the flexibility to fine-tune your Cassandra cluster for optimal performance, no matter your data access patterns. So there you have it, a crash course in Cassandra's compaction strategies. We've covered everything from the default STCS to the time-traveling TWCS, and even touched upon the outdated DTCS. Remember, choosing the right compaction strategy is crucial for optimizing your Cassandra cluster's performance. It's like choosing the right tool for the job. You wouldn't use a hammer to screw in a light bulb, would you? Although I've totally tried that before. IT didn't end well. Analyzing your data access patterns is key. Are you dealing with more reads or writes? Is your data time sensitive? Once you understand your workload, you can pick the strategy that best suits your needs. And hey, if you're feeling adventurous, why not experiment with hybrid strategies? Who knows, you might just create the perfect compaction cocktail for your Cassandra cluster. Thanks for watching, and don't forget to like, subscribe, and hit that notification bell for more data-driven adventures.